Chapter 7, Lesson 3, Simplifying Radical Expressions. If you have radicals or the same roots, remember radicals means roots, we don't have to convert them to exponents like we did in the last lesson. So as long as they have the same root, we can combine them based on our product rule for radicals or our quotient rule for radicals. So on this one, we check to make sure, yes, it's the square root of 3 and the square root of 5. So we can multiply them to make them the square root of 15. Same thing, square root of 21 times the square root of x becomes the square root of 21x. Cube root of 4 times the cube root of 2 becomes the cube root of 8, which according to our roots sheet is 2. Last one, fourth root. So it becomes the fourth root of 10 y squared x the third, and 10 is not a perfect root, so we leave it like that. On the quotient rule, we have the square root of 25 and the square root of 49, which they are both perfect squares. 25 comes out as 5 and 49 comes out as 7. The next one, we have the square root of x over the square root of 9. We cannot square root x, but 9 can come out as 3. Cube root of 8 over 27. The cube root of 8 is 2, and the cube root of 27 is 3. And the last one, the fourth root of 3 over the fourth root of 16 y to the fourth. The fourth root of 3 does not come out. The fourth root of 16 is 2, and y to the 4 over 4 becomes y to the 1. Okay, so now what we're going to do is we're going to create a square root sheet, and we can no longer do square roots and give decimals. So what we're going to do is try to simplify radicals by factoring out some perfect squares or perfect cubes or fourths or fifths. So when we're talking about the first one, it says the square root of 50. If I type in the square root of 50 in my calculator, it gives me 7.01. So I know that one of the perfect squares that is going to break up into there should be something below 50. So I look at all my perfect squares I have, which are 1, 4, 9, 16, 25, 36. And I figure out that 50 can be broken up into 25 times 2. Now, most of the time when you break up a root, it's always going to be one of your perfect squares and a prime. Not always, because there are some, like 10 is another common one that breaks up, but most of the time it'll be a perfect square and a prime number. So now I can break that up into the square root of 25 times the square root of 2, and the square root of 25 is 5, and 2 cannot be broken down, so we just leave that one under the square root. So now, instead of having a big number under our square root, it is a number out front and a prime. So on this one, I'm looking at the cube root of 24. So I have to look at all of my perfect cubes I have. And I know that I can break that up into the cube root of 8 times the cube root of 3. The cube root of 8 is 2, and the cube root of 3 is simplified. Next one, for 27, I can break it up into 9 and 3. The cube root of 9 is 3, or square root, and the other one stays inside the square root. The last one is 243. So I think of all my perfect fourths, and I'll try 243 divided by 81, and that worked. The fourth root of 81 times the fourth root of 3, and the fourth root of 81 is 3, so it becomes 3 fourth root of 3. So now we're going to start working with our variables, with our roots. So remember that taking the square root of the variable was the same thing as putting the variable to the 1/2, or taking the cube root of the variable was the same as putting that number to the 2/3 power. But when we're simplifying our variables, we don't want fractions. We only want whole numbers to come out. So sometimes we're going to have to break up our variables into numbers that can come out and remainders, kind of like we did with our perfect squares and our primes. Okay, so this one starts as the square root of 25 x to the third. So what I'm going to do is break it up because I know this is like a 2. So I'm going to leave the 25 because that can be broken up. And I'm going to break up the x to the third into 2 and 1. So the 25 comes out as 5. And then the x squared becomes x to the 2 over 2, which becomes x to the 1. And then this one would be x to the 1/2. And we don't want fractions, so we're going to leave that one inside. The next one, we have the cube root of 54, which for cube roots, 54 breaks up into 27 times 2. Then I ask myself, can x to the 6 be divided by 3? Yes, I don't need to break it up. Can y to the 8 be divided by 3? No, so I'm going to break it up into y6, y2. So the 27 comes out as 3. The 2 stays. X to the 6 over 3 becomes x squared. Y to the 6 over 3 becomes y squared. And this would be y to the 2/3, which is a fraction. So on the outside, I'm going to have 3x squared, y squared. And on the inside of the cube root, I'm going to have 2y squared. The next one is the fourth root of 81, z to the 11th. I already know that 81 is a perfect fourth, so I'm going to leave that. 11 cannot be divided by evenly by 4, but I could break it up into z8, z3. And then my final answer, the fourth root of 81 comes out as 3. Z to the 8 over 4 becomes z squared. And circle z3 that stay inside of the fourth root. The last one, I have the square root of 20 over the square root of 5. First thing I'm going to do is simplify that. So 20 divided by 5 would be the square root of 4. And 4 comes out as a 2. No variable in that one. Okay, so on difficult fractions, the best thing we're going to do is simplify first before we start breaking out. So on this one, it looks kind of odd the way I had to type it, but it's 7 times the cube root of 48 x4 y8 over the cube root of 6xy squared. So first what we're going to do is we're going to simplify under the fraction. So I have 48 over 6 would become cube root of 8. X to the 4th, x to the 1 would become x to the 3rd. Y to the 8, y to the 2 would become y to the 6th. So simplify first. Then 8 can come out as 2. X to the 3 over 3 would be x to the 1. And y to the 6 over 3 would be y squared. And now I just combine like terms. There's not a symbol here, so we know that that implies multiplication. So 7 times 2xy squared would be 14xy squared. On this next one, it looks like this. 2 times the fourth root of 32a8b6 over a to the negative 1b squared. On this one, I can't simplify my a's and my b's because some are underneath of my root and some are outside of my root. So actually what I'm going to do is I'm going to break them up first and then try to simplify afterwards. So I'm going to leave the 2. I'm going to move that a to the negative 1 to the top. To do the fourth root and check 32 is not a perfect fourth. So I'm going to break it up into 16 times 2. A to the 8th gets to stay because it can be divided by 4. B to the 6th, however, cannot be divided by 4. So I'm going to break it up into B4, remainder 2, still over B2. Now my 16 is going to come out as 2. Circle this 2. A to the 8 over 4 becomes A squared. B to the 4 over 4 becomes B1. And circle B2. Now I have 2 times 2, which is 4. A1 and A2 gives me A3. B1 over, or what the fourth root of 2b squared over b squared. And final example, or final answer would be 4a cubed, fourth root of 2b squared over b to the first. The next one, I have the square root of 12, which I know is not a perfect square, so I'll do 4 times 3. R9, you can't divide it by 2, so I'll do R8, R1. And S12 is fine to be divided by 2. Whoops. Okay, so the 4 comes out as 2. The 3 gets circled. R8 divided by 2 comes out as R4. R1/4 we don't want, so we leave that circled. And S12 divided by 2 would be S6. The square root would be left with 3R1. The next one is the cube root of 8, which is a perfect cube, so 2. A to the 6 over 3 would be A to the second, and B to the 9 over 3 is B to the third. The next one, I have the square root of 270y squared over 5, square root of 3y to the negative 4. So I'm going to do 270 divided by 3 to become 90. And I also need to move this y to the negative 4 up to the top. So now I'm going to have the square root of 90 y squared y4 over 5 is all that's left because I divided those and my y went away. 90 is not a perfect square, but it breaks up into 9 and 10. And y to the 6 can be divided by 2, so I'm going to leave that over 5. The 9 comes out as 3. The 10 gets circled. Y6 over 2 comes out as y3. Square root of 10 over 5. And the last one, the fourth root of, so I'm going to take 160 divided by 2, which is 80. X10 over X2 becomes X8. And Y5 over Y2 becomes Y3. 80 is not a perfect fourth. I'm not even sure that 80 breaks up by anything. 80 divided by 16 and 5, it does. X8 can be broken up by 4, and Y3 will get circled. The fourth root of 16 is 2. X8 over 4 becomes X2. And underneath of my fourth root is 5y to the third.